When we talk about dimensions, we are really just talking about directions. Let's drop down to where the count begins, the 0th dimension. Here, there are 0 directions to move. You exist as a single point with no size at all, trapped in a world where the very idea of movement has no meaning. We can grant you one direction of movement by stretching that point into a line. Now you have length, meaning you can slide forward or backward. Pull that line sideways and you gain width. This is the 2nd dimension, a world as flat as a drawing on paper. If you draw a square house around yourself here, you are hidden. To any neighbor sliding along the surface, your walls are an impenetrable barrier. There is a specific limitation to living on a flat surface. In 1884, mathematician Edwin Abbott explained that a creature perceives the world through a perspective one dimension lower than its own. If you lived on this paper and looked at a round coin, you wouldn't see a circle. Viewing it from the edge, you would only see a flat, straight line. You would feel perfectly secure inside your 4 walls because no one in your world could see over them. But to someone looking down from a higher dimension, your fortress is just an open box. Every part of your world is visible to them at the same time. To find our own world, we pop that flat drawing up to add depth. This is the 3rd dimension, the space we navigate every day. Because we have that extra direction of up, we can reach into a 2-dimensional house without breaking its walls. We have a vantage point that the flat character can't even imagine. However, Abbott's rule still applies to us. We live in 3 dimensions, but we see in 2. When you look at a locked safe, the flat metal of the door blocks your view of the money inside. Your brain uses shadows and angles to create the feeling of depth, but you are only ever seeing the outer shell of things. Since we can't see the insides of objects without breaking them, we are just as limited in our space as the flat character was on their paper. To see into our world, we have to move higher. To find a new direction, we have to look past physical space. In 1908, physicist Hermann Minkowski proposed that we treat time as a physical path we can measure. By adding time to our 3 directions of space, we create a single structure called space-time. To a being in the 4th dimension, time is not a flowing river. It is laid out all at once, like a video editor looking at a computer screen. While we watch a movie frame by frame, the editor sees the entire strip of film resting on the timeline from the first second to the last. If you were a 4th dimensional object, you wouldn't be a person moving through a room. You would be a solid, unchanging shape, a long space-time worm that begins as an infant at one end and stretches through space until you take your last breath at the other. Your life is a static object that a 4-dimensional being can see in its entirety. To them, no safe is truly locked. They don't need to break the door today. They simply reach back to the moment yesterday when you had the door open. But that single space-time worm only tracks one version of events. Physicist Hugh Everett suggested that our universe allows for every possible outcome to occur. This brings us to the 5th dimension, the direction of probability. Imagine your life as a series of crossroads. Every time you make a choice or a random event occurs, your single timeline forks in 2. These branches then split again and again, creating new paths for every possible outcome. In the 5th dimension, every version of your life exists simultaneously as a physical direction branching outward. You occupy an entire forest of every person you could have become, from the version that moved across the country to the version that stayed home today. Instead of a single story, you are now the sum of all your possible choices. For a being here, there is no one path you must follow. They see the entire tree of your potential as a single, massive shape. As vast as that tree is, it only shows what can happen within the laws of our universe. To go further, we have to take that entire collection of possibilities and shrink it back down into a single point. If that point represents everything possible under our laws of gravity and light, then moving in a new direction from that point takes us into the 6th dimension. Here, we find universes where the basic settings of reality are different. In these worlds, gravity might be far stronger, or atoms might never form bonds. our physical bodies couldn't exist here because the chemistry that holds us together wouldn't work. In the sixth dimension, you are no longer a physical creature. You become a map that links together every way a universe could be built. You are the bridge between all the different sets of rules that reality can follow. Finally, we take all those different sets of laws and group them together into the seventh dimension. Think of this as a library that holds every reality that is logically possible to imagine. This space contains everything that could ever be. Because every timeline and every law of physics is already present here, nothing ever changes or moves. It is a vast, unchanging map of all existence. It is difficult to picture because our brains evolved to survive in a three-dimensional world, not to wrap around this scale of complexity. So let's come back to where we started. Look around your room. Time is moving forward normally, and the walls of your house are solid once again. We are navigating just one small path through that giant library, but this limited view is exactly what makes our world feel stable and real. To understand higher dimensions, we have to stop trying to picture the impossible. Instead, we have to learn how to read their footprints. Imagine a wireframe cube floating in the air, casting a shadow onto a flat surface below. The cube has depth, but its shadow is completely flat. Even though that shadow is trapped in 2 dimensions, it still carries information about the object above it. As the cube rotates, the flat shadow stretches and shifts on the table. A creature living entirely on that flat tabletop could never look up to see the cube, but by watching the shadow's behavior, they could use mathematics to calculate the exact shape of the object they can't perceive. This is the method scientists use to explore the 8th dimension. They study the mathematical shadows these shapes cast into our 3-dimensional world. In mathematics, adding a dimension is a matter of adding a new variable to an equation. Each new variable represents a new degree of freedom. When we calculate a 4-dimensional hypercube and projected shadow into our space, we see a shape that looks like a box constantly folding through itself. If we add a 5th variable, the math calculates a 5th direction. The shadow becomes denser, filled with new lines that intersect at angles we can describe even if we can't see them. We can push the equations further, adding a 6th and a 7th direction. The projection becomes a rapidly shifting web of corners and edges, all moving independently. Eventually, we arrive at the 8th dimension. The equations stabilize into a complex, perfectly ordered geometric shadow. 8-dimensional space functions as a precise mathematical arena where every object has 8 independent directions of movement. Within this arena sits one of the most complex shapes in mathematics, the E8 lattice. This structure consists of 240 vertices, all perfectly balanced across those 8 different directions. This image shows the shadow of the E8 lattice projected down onto a flat 2-dimensional screen. Notice the concentric rings of red dots. Every dot represents one of the 240 original points, capturing a symmetry invisible to the human eye. This pattern represents more than an abstract calculation. Physicists are investigating whether this specific geometric shadow explains the way the universe is structured at its most basic level. If we zoom past atoms and deep into the subatomic realm, we find a world that our current theories struggle to explain. In our 3-dimensional world, the rules of gravity and the rules of quantum mechanics often contradict each other, leaving us without a single description of how matter behaves. String theory proposes that the universe is made of tiny vibrating strings. For these strings to vibrate in ways that produce the forces we see, they require extra curled-up dimensions. The E8 lattice provides a framework with enough mathematical symmetry for these strings to exist. Its unique structure offers a space where these competing laws of physics might finally align. Theoretical models have attempted to map every known particle and interaction in our universe onto the vertices of this 8D structure to see if they fit together as one cohesive whole. We may never evolve a brain that can see the 8th dimension, but as long as we can learn to read the shadows, we can still learn how the universe works.